Here's the review sheet for graphing rational functions. So it's in this form, p at x divided by q at x. That's a rational where p and q are polynomials. The x-intercepts is when you take the numerator equal to 0, and the vertical is when you take the denominator equal to 0. We have a horizontal asymptote. If the degree on top is bigger, there is no horizontal. If the degree is smaller on top, then it's y equals 0. And if they have the same degree, you take the power term divided by the power term, and you'll get some number, not 0, for the horizontal. There's a hole if a factor divides out an undefined point is created on the graph. That's what a hole is. So a hole is an undefined point. If a factor divides out, that's what it creates. And then we're going to practice. So we have 2 questions here for review. Can you graph this? What would it look like? So if I look at the first one, this is going to give me another oblique. So it's okay. Maybe that we've already done the lesson on oblique, so it's going to be okay. So I'm going to factor out the numerator. This is called the difference of squares. You square root plus and minus 3. So the x-intercepts are the zeros of the numerator. So that's positive and negative 3. So I'll go to positive 3 and I go to negative 3. There's no hole because nothing crosses out. The vertical asymptote is the 0 of the denominator at negative 2. So I go to negative 2 and I draw a line. The domain is that, but it can't be that. The horizontal, when the top is bigger than the bottom, I have to divide. So I take the 0 of the denominator and I divide it into the numerator. The remainder doesn't have an effect on the line that you're drawing, so I drop the 1 down. Negative 2 times 1 and add. Those are the numbers that give it to me. So this is oblique, so I'm going to cross this out and write down the word oblique. And that is y equals 1x minus 2. So to graph a line, I start at the y-intercept, negative 2, and then I go up 1 over 1, and I draw my line. So that guides me in terms of what the curve is going to look like. We'll ignore the range right now. I do want to know the y-intercept. So for the y-intercept, again, if you plug in 0, the last number, and you plug in 0, the last number, that gives me negative 4 over 5. So I'm going to go to 1, 2, 3, 4, negative 4.5. And now I have a curve, and I have a curve. And that's what it looks like when you have an oblique, that slanted asymptote. This actually is all numbers from the bottom to the top. So the second one, when the degrees are the same on the top and bottom, this will be more a traditional rational. So one-step diamond, that's negative 5 and positive 1. The denominator is a difference of squares. So square root x squared, and you square root 1. So 1 is positive 1 and 1 is minus 1. So that already gives me the domain that x cannot equal positive and negative 1. Something does cross out here. So I'm left with x minus 5 over x minus 1. What crossed out, we make equal to 0 and solve that. Subtract 1. That's the x coordinate of the hole. To find the y coordinate of the hole, plug in negative 1 for x and solve it. So that's negative 6 divided by negative 2. The negatives make a positive 3. So I go to negative 1 and 3. There's my hole. The numerator gives me my x-intercept, which is 5. The denominator gives me my vertical asymptote, which is positive 1. There is a horizontal. If I take the power term divided by the power term, x squared divided by x squared, that's 1. I like the y-intercept. So if I go back to the beginning, when you plug in 0, the last number is -5 and the last number is -1. Divide, that gives me 5. And then I can then draw the curve with the hole in the y-intercept. This is going to have some symmetry this way. The range, so the y-coordinate of the hole and the horizontal asymptote. I didn't do this. I need to go back. The end behavior here. So for an oblique, when I look at the right end is pointing up, so that's infinity. The left end behavior, when I'm looking at the left end, it's going down. So the left end behavior is going to -infinity. So there's the end behavior for the oblique. For the one we just did, which has a horizontal, it goes to the horizontal number, which is 1. So as x approaches infinity, f at x approaches 1. As x approaches -infinity, f at x approaches 1. All right, so there's a review, quick review, in terms of a rational function and all the layers involved to analyze and graph. Mr. G Math, over now.